So welcome to today's first session. This session is part of a series on kindergarten through grade 5 inclusive practices in mathematics. And today we're going to be focusing on technology and how we can use technology to provide access for students, but also to enhance students' learning in mathematics. As we've been talking about inclusive practices, we want to think about how we can build on students' funds of knowledge and their interests. And technology is often one way to engage some students with mathematics learning just because of the technology and the use of visuals and a device, etc. We want to nurture belonging and community. So thinking about what it means to be in community when we're using technology and emphasizing some of those key principles about digital literacy. We want to present and represent mathematical ideas in different ways and through different modalities when teaching, and technology offers us so many opportunities for that. Technology also offers us opportunities to create choices for where and with who students learn. There's opportunities for collaboration, as well as taking turns and sharing devices. And then creating choices for materials, tasks, ranges of numbers, and then access to tools and different types of technology to support student learning. And then one of the really sort of strong points, I think, for using technology in K-5 is that it allows for different ways for students to represent and share and communicate their learning. And we'll talk about some of those things in this session. So going back to our core ideas of universal design for learning, knowing that learners, there's a range of learners in our classes, and that's the rule, not the exception, that there's learner variability. We have firm learning goals for all our students connected to grade level learning standards and expectations, but there are flexible ways and supports to help students meet those goals and work towards those goals. And then we're creating opportunities for learner agency, where we're removing biases and barriers so that students can advocate for themselves and have agency through choice and some of their personal decision-making around mathematics. So Katie Novak and Ashley Marlowe in their UDL book specific to mathematics talk about that multiple means of engagement, multiple means of representation, and then multiple means of action and expression are particularly important in mathematics teaching and learning. The resources that we're drawing upon for these series include that book by Katie Novak, but also Rachel Lambert's work around rethinking disability and mathematics, and also thinking about culturally sustaining and pedagogical practices and drawing upon books like Cultivating Mathematical Hearts and Culturally Relevant Math Tasks, again, to create that sense of connectedness and belonging and inclusive practices in our math classes. When we use technology to provide access and a tool for communication, there's already so many resources available to provide this information to you on Learn38 on RichNet. So at the bottom of the screen here, again, if you go to Learn38 and you go to the digital literacy section, which is under planning, and then you click on accessibility, there's detailed information about all these things that you can see here on the screen. So how to use voiceovers, how to do text to speech and speech to text, how to create different font sizes and use different styles and colors for students who need access for readability. There's physical and motor accessibility features such as assistive touch and different keyboard options for some students. There's closed captioning that may be provided in English as well as in students' home languages if English language learning is a support that they need. One of the tools that I use often in Microsoft PowerPoint is that when you provide closed captioning when I'm teaching in a classroom, if I've got slides that I'm using for example, a routine like a same but different or number talk images, and I've got that slide up there with that image, I put on my closed captioning and I can increase the size of that as well. And it does provide some students some access who might have need hearing support or listening support, but also some students who can access reading as opposed to listening, and that might be a strength for them. So that's one thing that you can include when you're using PowerPoint slides. And then uh, being familiar with the devices that you're using in your classroom, whether it's iPads or if you've got laptops in, about those accessibility settings and guided access through the settings tool that you can provide for your students. And again, more information about dictation and immersive readers are available under the Learn38 digital literacy page on Learn38. Some of the resources that I draw upon regularly to provide students choices for representation and communication, as well as in my own teaching, are the ones on the screen here. So Mathagon Polypad, if you go to mathagon.org, it's a public website, nothing costs anything. They have a whole huge suite of different mathematics manipulatives as well as tools that that you can use. Sorry, I just checking something there that you can use to project in the class or that students can use to represent. So you can be dragging different tools onto the screen as you're teaching. You could have something prepared that you share with your students, but students can also use this on devices as a representation of their learning. Physical materials are always important to use. There's a special type of learning that happens with those materials and the mathematical connections that students make. But sometimes for representing student learning, those virtual manipulatives can be a really important tool, as well as projecting as the educator so that all students can see as well. So that's how I often use those ones. The Math Learning Center also has manipulatives and tools. They're both iOS and web-based apps, and these are all in self-service if you're using Richmond devices. So the number frames, number line, number pieces, which are like base 10 blocks, fractions, geoboards, math clocks. There's all sorts of different math learning manipulatives and tools, again, that students can use to represent and communicate their understanding, but you can also use as a teacher as well. And then screencasting is when that you might have a photograph or a drawing or a diagram that you have on a device or screen, and then you're using oral narration as well as annotation to share and communicate your thinking. So just as an alternative for a student to share their learning in different ways. And the one that Chris Lode and Jonathan Tang have been recommending is Doceri. I've used that one for years. It's almost over a decade now. And I'm going to share an example of a screencasting example around sort of summative assessment as one way, one choice that you might provide for students to show what they've learned. So just we'll share some examples of that. These are some examples from a grade 1 class. And again, how they were using an iPad. They were learning about the values and the attributes of different coins. And so they took pictures of their collection of coins. And you can see here that they've labeled it. And then they did then an oral annotation talking about, the 5-cent one has a beaver on it. And the brown colored one, the shiny brown one has a maple leaf and it's worth 1 cent. So they were talking, using the attributes of the coins and talking about them in their oral screencasting. This is an example from grade 4 and 5. So they actually built their understanding of halving and doubling with multiplication with math manipulatives. And then they took photographs of those and annotated them. And then that was what was submitted to their portfolio so that they could have a record of what they did and that annotation explaining their understanding. And again, the recommended apps for annotating are Sketch, Freeform, or Pic Collage. Another example from grade 4 or 5, we gave them a choice as to what apps they might want to use to show what they know about fractions and decimals. So this was partway through the unit of study, and it was just sort of a check-in, show us what you know, show us what you understand using pictures, numbers, and words. And this is what students submitted, and it gave us a sense of where students were in their understanding. This is in another grade 4 or 5 class where we were learning about tenths and hundredths and connecting fractions and decimals. And so this was the Number Frames app. So the students can adjust that to a 10-frame app or a 10 by 10 grid. And then they can insert different, either circles, or here they've inserted little frogs and penguins to represent 30 hundredths or 70 hundredths, and write the fraction and write the decimal equivalent as well. And then take a screenshot of that, and then that can be posted again and shared with their teacher. So here's an example of a screencast. Again, the student used a physical geoboard in this case to create 3 different rectangles. And then we were studying area and perimeter and the relationship between area and perimeter. This was a grade 4 student, and I'm just going to play their little screencast so that you get a sense of how much the student has learned and what they're able to tell us through this particular medium using technology.
All these rectangles have a perimeter of 12. Perimeter is the distance around a shape. This rectangle over here has a perimeter of 12, but only an area of 5. Area is the amount of surface a shape covers. This rectangle over here has a perimeter of 12, but only 8 area. This rectangle over here has a perimeter of 12, but 9 area. As you can see, the rectangle with more of a square shape has the most area. Area can be measured through square units, such as square centimeters or square meters.
All right, so I think hopefully you can see sort of the power of this option. This was one of the choices that students had as an opportunity for them to show us all that they had learned about area and perimeter as their summative assessment. So again, some more recommended iPad apps for representation and communication and practice. So we have a suite of Math Tappers apps that were developed at the University of Victoria that are available through self-service for our devices. We have a suite of Mathies apps, which were developed by the Ontario Association of Mathematics Educators. That includes a Canadian Money app that students can move around and create different combinations for. Touch counts and touch times. One app is around counting, one app is around multiplication and grouping. Those were developed at Simon Fraser University. They're available in multiple languages and involve the use of gestures. So that's sort of kinesthetic gesturing with the iPad. And then, as I mentioned before, the Math Learning Center, virtual manipulatives and tools. And then Desmo is one that's generally used with intermediate through secondary students, but I have used it at the grade 3 or 4 or 5 level. There are established tasks already on the Desmos website that you might want to access as a teacher to share with your students. So I just wanted to point that out. Again, for choice, for practice can take all sorts of different forms. One of the things that I often do during math workshop is I might have 4 to 5 or 6 iPads that are locked on the app that I have chosen. So for example, here I've chosen the Find Sums app. And so the children are practicing, addition complements, but they're choosing their number range and they're also choosing the visual support that they want. So this is that sort of UDLing using the apps that we have available. Students are all using Find Some apps, but some of them might choose, addition to 10. Some of them might choose addition to 20. Some of them might choose addition to 100. They're choosing the number range that they're comfortable with. And as you can see in these middle ones here, they have the Apple 10 frame, and it's that visual support. If they click on 8, they can visually see how many more they need to fill up the 10 frame. So then they click on the 2, and that shows that it's filled up. The next sort of stage is just the symbolic notation. So if I clicked on 86, it doesn't give me any sort of visual support other than I need to figure out what goes in that missing box. And so I need to do some mental math calculations before I click 14, and then that is correct. So again, students can use the same app, but at a range of number levels, and then again at a range with different visual supports. So that whole suite of Math Tapper apps is like that. On the right, you see the estimation fractions app that I just recently used with a group of grade 4 and 5 students during math workshop. And again, the students could choose the types of fractions that they used, the number of fractions that they had to estimate and places, on the number line. So again, more information about all these apps is available on the district's app list, which is under the digital literacy page on Learn 38. Some more examples on the left here are examples from the Math Learning Center, the Numberline app, and the Geoboard app. And then this is the Touch Counts app on the right. And so again, if students took one finger and put it on 3 and one finger and put it on the 2 at the same time, and then with their fingers sort of mushed them together, they would combine and it would now say 5. This is what happened with this 6 over here. So for again, that really beginning understanding of combining, composing, and decomposing numbers, touch times and touch counts are great apps for that. Again, more information. This is what it looks like when you go to the iPad list on the digital literacy site on Learn 38. So there's the Math Learning Center apps, the Math Tappers apps, and the Mathies apps from Ontario. So, quoting Katie Novak and Marlowe, incorporating technology into math assignments can expand students' choices for expressing their mathematical ideas. And we know that that choice and that agency is such an important piece of UDL and thinking about planning and designing for learning in our math classrooms. A new initiative that is happening around technology in our district is the use of artificial intelligence and really thinking about generative artificial intelligence technology. We currently have a pilot happening in our district and thinking about the benefits and some of the concerns and issues around using artificial intelligence and the different platforms or tools that we'll be using for that. So some of the strengths of AI is its ability to simplify language or change language for different lexical like levels and grade levels, to be able to differentiate the text, to translate to the home language when necessary for communication. Um, able to use AI as a teacher to generate questions and problems for students. And that students are able to interact with a chatbot, or as a teacher, you're able to interact with a chatbot to engage in mathematical thinking or problem solving together. One of the things that we have found through our own sort of explorations and investigations is that AI is not very strong at doing the math. So often, if you ask it to do math for you, it will come back and say, "Oh, well, how might you start?" Or it'll give you a prompt back instead of giving you an answer. So you can't just sort of do a question and say, "Is this right?" The chatbot won't engage with you that way. So it's not really meant for that. It's so we need to sort of think about how we might use that as teachers and then how we might use that with our students. So in our district, again, we're piloting the use of Magic School and School AI, and some teachers in our district have signed up to look at those. We also have the access to Copilot through Microsoft 365 and their suite of apps. So I've played around a little bit with Magic School just as one example, as a way to sort of think about how to um, support my planning and designing for teaching and learning. And so, here's Raina, here's the AI, she's the chat bot, and I entered some question. What are some strategies for adding two-digit numbers? And so that was just sort of a conversation I had, and these are, the strategies that she shared. And again, we have strategies in our BC curriculum, but this generates some examples as well. So that might be useful for a parent that is trying to support their child at home. It might be something that you could recommend or that you could use as a basis to generate something that you could share with students or with families. It has a vocabulary list generator. So again, I entered some prompts. I was doing grade 2. We were looking at addition. We're using the BC 2016 curriculum. You can enter all those prompts so that it refines it's how it generates the information that it generates. It's really important to put 2016. That's our most current curriculum. I found out through trial and error. That otherwise it just sort of gathers everything that's out there on the internet related to British Columbia math curriculum. So again, it creates this vocabulary list for me. And yes, it might miss some things that I'm thinking about, and I can add those, but it also might like, oh yeah, I forgot about that one. So again, it's just a tool to support you in thinking about how to support your students as you're designing for learning. It also has a UDL choice board option. So again, I'm going to put in my prompts, addition strategies with two-digit numbers. This is for grade 2 using the BC 2016 curriculum. I want to make sure that we're including oral opportunities, using concrete materials, pictures, and then written options as well. And so this is what it generated for me. I don't know that I would do a partner quiz or some of these other things that are suggested there, but I hadn't thought of some of them. And again, as I'm creating my choice board or my menu or my pathway, whatever it is in terms of, math for math workshop, the students' choices, this might be something that supports your planning and designing. One of the things that I found very helpful using generative AI, and again, it's all about the prompts that you put in, but I often get emails from teachers like, is there a bank of, problems somewhere? And so I just generated 3 pages, I think I put in. I can't remember what I put, 2 pages of addition word problems for grade 2 addition. And so I put in second grade, it's an American platform, math word problems, 2 pages of word problems, and then some of the prompts that I added or the tags were CGI, so cognitively guided instruction, and then I specifically wanted change unknown problems, and then I added the BC 2016 mathematics curriculum. And you can see this was like the app that I used down here, math story word problems. These were the prompts that I gave it, and then this is what came up. And I was actually quite pleased how aligned it was with CGI and with our curriculum. And again, I can change the names here in the problems if I want to, but now I have a bank of problems that I can draw upon, and it gives you an answer key as well in this particular case. So think about what different ways you might use AI to support planning and designing for mathematics learning in your own practice. And then when we think about using AI, generative AI technology with kindergarten to grade 5 students, I think there's still lots of things that we need to consider. Um, Bias and accuracy, uh, again, it's AI, it's artificial intelligence. So not everything is going to be accurate. There might be bias that's being held or communicated. So we need to have a lens or a filter to think about that when we're using this kind of technology with our younger students. Privacy, digital literacy, understanding the limits of AI, and I think most importantly is why would we use it? What is the purpose? What is the intention? And that's part of what the pilot in our district is currently looking at. And then there will be guidelines for its use in the fall going forward. There will be ongoing resources shared to our inclusive practices tile on Learn38 on RichNet, including more information about AI and some of the apps and things to use to support the use of technology in your classrooms. So as we close today, I'd like you to think about how might you use technology to provide greater access to learning mathematics? How can technology be used to provide agency and choice for students in terms of practice, representation, and communication? What might AI offer in supporting your planning and designing for mathematics learning? I'm hoping that maybe something new was shared with you around AI. I'm still learning a lot about it and sort of playing around with it myself, but I think there's lots of possibilities for planning and designing for teachers. So thanks for joining me for this second to last session in this series around inclusive practices in K-5 mathematics.